So good morning, everyone, and thank you for joining us this morning to discuss modernization and migration of on-prem legacy analytics and data platforms to cloud-based solution architecture. I'm Jeff Meck, and I'm a customer success lead at UserReady. This morning, I'm joined by two of my colleagues, Jayaprakash Sivanandan. Jayaprakash, otherwise known as JP, is a lead solution architect with UserReady, specializing in Tableau, AWS, and Snowflake solutions with over 15 years of experience. I'm also joined by Deepak Bambani. Deepak is a director of data analytics with UserReady and has worked with large UserReady customers to migrate their legacy on-prem data and analytics platforms to modern platforms. Next slide, Deepak. Deepak, can you go to the agenda, please? Okay, so as part of our discussion, we'll first touch on the drivers of modernization and the business value of modern cloud analytics and data platforms. However, the focus of today's webinar will be on migrating a Hyperion IR analytics on-prem environment to a modern architecture composed of Tableau Server, Snowflake, Cloud Data Warehouse, and Amazon Web Services. And we'll discuss our proven process and accelerator used to help our customers with their Hyperion migrations. Our discussion will also include a brief introduction of Tableau Server, Snowflake Cloud Data Warehouse, and AWS Amazon Web Services as a best-in-class solution for data and analytics platform modernization cloud. We'll keep the introduction of these best-in-class vendors short, but given our audience, we wanted to at least share some basics relating to the value proposition of these solution components. If you'd like to hear more about any of the individual vendor technologies and solutions, just reach out. We'll have contact information at the end of our session. Next slide. Next slide, please. Okay, so just a little bit about UserReady. So at UserReady, we empower people to succeed with data. Specifically, we're a data and analytics firm that provides the strategies, tools, capability, and capacity that businesses need to turn their data into a competitive advantage. Among our partnerships and technical competencies, we have partnerships with Tableau, AWS, and Snowflake. We're headquartered in New York, and have offices in Bangalore, India, New Jersey, Chicago, and Toronto. Next slide, please. So as you'll see on the webinar, you have the ability to type your questions in to the right, and please go ahead and do that as we go through the webinar. And at the end, we'll address questions and move forward from there. So let's start quickly with some drivers and value of a modern analytics and data platform. So first, with respect to modernization drivers, we're seeing a significant increase in organizations seeking to become more data-driven. So in this case, the use of BI and analytics platforms is growing very fast, and modern analytics capabilities are in demand by the business users. With this growth, the organization's usage is outpacing resource capacity. In other words, IT resource consumption is outpacing on-prem infrastructure resources. And further, with this increase in demand, organizations are realizing that the associated usage fluctuation and the need to support peak loads can make maintaining on-prem platform infrastructure cost prohibitive. So what business value are organizations looking for and receiving from modern data and analytics platforms? So first off, organizations are achieving data-driven decision accuracy. Value is recognized in the engagement of the business and the accuracy of data-driven decisions over gut and instinctual decisions. Additionally, we see proactive versus reactive analytics. KPIs and other measures can be easily managed and reported in a proactive fashion versus reactive, enabling more timely decisions. Additionally, we can guarantee performance because of unlimited capacity and scale supported by cloud infrastructure. As resources are needed, they can scale up for peak loads and scale down for reduced loads. And lastly, cost control can be reduced. Costs can be reduced or maintained as usage grows exponentially. So before we transition to how we accelerate Hyperion IT or IR migrations to Tableau and Snowflake on AWS, let me share some information about a few financial incentives. So the first is through AWS. AWS will fund 10% of the year one annual recurring revenue for your migrated Tableau Server workload to AWS to offset costs. And additionally, Tableau competitive takeout marketing funds can provide up to $5,000, and this $5,000 can be matched by UserReady. So with that, I'll hand it over to Deepak to take us through the migration process and accelerator demo. Thanks, Steve.
Thanks, Jeff. First of all, I would like to welcome everyone. I saw the attendee list and I see people are joining from different parts of the world. So good morning, good afternoon, or good evening, depending on where you are. So in the previous slide, Jeff just spoke about the different drivers for data modernization or data platform modernization. And as we talk about Hyperion or Brio, what we see is that reports are now transformed into KPIs. The report distribution component is now turning into an analytics dissemination. Similarly, the concept of report factory is more replaced with self-service analytics. Historical reporting goes into real-time or NRT type of analytics. And basically, it's all about enabling decision makers with data and BI tools, right? So the key difference that we see with the migration is the speed to insight. And that's what most companies and companies that we work for or work with are excited about. So let's talk about migration challenges, right? Especially if you have a large Hyperion or Brio footprint, say in tens of thousands of reports. Even before you start the project, right? These challenges are pretty obvious. First of all, it must have, you could have had your Hyperion or Brio environment for decades. Tens of thousands of reports. Right off the bat, that is extremely time consuming. Change management, business readiness and other components also play a key role. Your resources are limited because, over the years, you've created so many reports, the business, the different analysts that may have already left the company. So there is a limited set of your Hyperion experts and your data experts that can help with that lift and shift with that migration. What we land up seeing with migration really is, and these last 2 points are more of our observation, is that these planned migrations land up in a spot where you land up with two infrastructures to maintain, which means you don't sunset your legacy system and you have onboarded a lot of your content into your modern data analytics platform. And once again, as you go through these big number of reports, what tends to happen is the thought comes back to just lift and shift. If we have 100 reports for this department, let's do a quick audit to see what reports are needed. And once you know which ones are needed, you just start lifting and shifting and migrating them over. So first of all, why are we here? We know that Brio or Hyperion IR is kind of at end of support. And what this brings us to is organizations that are migrating out of Hyperion have many opportunities to and options to transform. And the path forward is really the way is what we want to talk about today, is UserReady's unique approach for Hyperion migration. So the first part is we have a framework uh, that's definitive and repeatable. And we use a lot of automation and accelerators that can help reduce the migration time by more than 60%. So I'll quickly go over this slide because I really want to use the time today to focus on the migration, the accelerators, the automation, and put in a demo just to bring all that together. So what is involved in migration? All the components of Hyperion, right? The BQI files, you have the jobs, the reports, your connections, distributions. If you use data models for people to use in self-service, you have that component. Excuse me. And this brings us to our framework. So everything you see in left over here, this box, is your legacy platform. What you see in the middle over here is the framework. That's the part that I want to talk the most about today and demo out certain components of that. And what you see on the right over here is your future state platform with Tableau on AWS and Snowflake. Now, coming back to the first block over here, what we what our framework works on is a complete audit and the metadata or the analysis of the metadata that we get out from your Brio Hyperion reports, your BQI files, as well as your repository tables. So what are we looking for? We are looking for things like user groups, folders, schedules, security, event triggers, if you are using triggers, what kind of recurring frequency do you have for your data warehouse, distribution in terms of where are all the files going? Are they going to a network drive? Are they getting emailed? Obviously, we want to look at reports and jobs, like what reports exist and where, right? Are you using BQIs on a network drive? How many of them do you have on the repository? You want to look at users, whether they're active, inactive, using logs, whatever usage that you could gather. And then a complete analysis in terms of the system inventory and impact analysis on the utilization of your data. Particularly, the main focus over there would be the columns and tables used, the kind of joins, calculations, filters, because this component, this last piece, right, of the data that is used in your reports would also be what would drive the design of your certified Tableau data sources for both for migration as well as for future self-service. So with that being said, I'm quickly going to go into a quick demo. So the first part of our utility of our framework is about getting that audit data out of your repository tables or your reports on your network drive. And the first part of that piece is an extractor script. So what the extractor script does is it pulls some metadata and calculations out of your BQIs or your published jobs, your reports. The idea behind that is once we have that metadata, we can help with rationalizing of the reports and help consolidate the report footprint in terms of what reports need to be migrated and help with that accelerated migration. So in terms of the local files that you would have on your network or your folders, the process over here would be, we can do different types of analysis in terms of the SQL that the reports use, the tables, columns, joins. Do they have local joins? Are you getting external files like Excel files? And all that kind of metadata is collected in for rationalization of these reports. So once you select the reports you want to look at, or the folders that you want to analyze, or the folders where you have stored your BQIs, you can run the process, the extractor process. So as you see over here, the extractor really in this case is a crawler. It opens your BQI one at a time and starts pulling information out of your Hyperion BQI reports and starts putting them in Excel. Once it's in Excel, we can use this information, or we can put it in a database for further analysis, and we'll definitely take a look at that in the next few minutes. We could also do things around looking at what are the SQL or SQL or the exchanges that a BQI or a report has with the database, with the backend, in which case you would want to collect all the SQL statements out there so that you can do that analysis. Once this metadata is collected, I'm just going to go back to the slide. So all this metadata is now collected, and it goes into our framework in the recon phase. This is where we start looking for dependency trace. We start looking for mapping, and I'm going to go to example of mapping of these metadata files. Now, once the metadata is collected, in this case, I'm showing an example of the SQL statement. We now looked at these reports, especially when you're looking at thousands of reports. It's not possible to open each report and see what's under the hood, right? Let me just think of it this way. I have two reports open over here. So Jeff writes a report. It's a simple report with 3 to 4 tables. It's about some planned actuals. Over time, I realized that Jeff has this report and I need something similar. So I contact Jeff. Hey, Jeff, can you send me your BQI file? And I make a copy of it and I call it details query, right? I've renamed it. And in this case, you see, I have not changed anything. I added one more table, but I'm not using that table, so you won't see it in the SQL. And I just changed the sorting of some of these fields over here. I have not even added a single extra field. But if you were to open, or a data analyst who was to open these two reports, there's no way of that person telling that these are same reports, right? The names are different. The report layout, it looks completely different. Yeah, maybe you could go to the SQL, right? So even if you look at the SQL for these reports, right, it's a long SQL that you have to go through to ascertain whether two reports are similar or the same. You could have a third example where the reports are the same in this case, but I have one extra field. So think of the first report as something along the lines of select first name, last name from customer, and I have this report that is select first name, last name, phone number from customer. But looking at the reports, you could never tell that the two reports are, in this case, similar, not identical. And the first case, they were identical. It was just that the sort order was changed out, was swapped out. So with this concept in mind, and having an ability to automate the collection of this SQL statement, joins, filters, and calculations using the extractor scripts, we came up with an idea of looking at a report as a story. So you think of a report as a story and then look for similarities within this. So when you run this through through our algorithms, you come back with a similarity score. So if in the first case where the fields were not in the same order, but the tables and joins were the same, the fields were the same, just in a different order, it would come back with a cosine score of 1, which means these reports are identical. If they still have similarities, where the example of select first name, last name from customer, and the other one being select first name, last name, phone number from customer, if they are that similar, it would come back with a closer cosine value, right? So this was the starting point of how we started looking at reports for consolidation. And then obviously it went a step up, right? When you started looking at tens of thousands of reports, we broke our analysis of this into 2 distinct buckets. The first bucket is around the core, the tables and joins that you're using. So once we have all this metadata for thousands of reports, we run it through some ensemble methods to create clusters. The first set of clusters called core clustering. What the core cluster does is it logically maps all reports that use the same tables and joins into a bucket or a logical group or a cluster. The second part of it is once you have clustered your reports, we run it for similarity check. We already know that the tables and joins underneath that query is the same, right? So now the difference is around the select statement, right? Whether it is select first name, last name from customer, whether it's select first name, last name, phone number from customer. The reason we do the similarity mapping also is at the end of the day, right, there is a mountain of work. You have tens of thousands of reports to migrate. So the concept of our framework is where can we save time? Every place that we can save time, the automation for the extraction of the metadata, that saves time because you don't have to manually open 10,000 reports. Then the clustering of data so that you can start bucketing your reports. Obviously, we spoke about the deduping aspect of it because it's going to identify duplicates and save time with that. But the end goal was to create a mapping that would help for and speed up the redevelopment of these reports in Tableau. So now that we have our clusters identified, I'm just going to change my screen. Here is a sample of 95 very unique reports that we came across. We didn't think we'll be able to cluster them because they were already predefined, pre-audited. But as we ran through it, we were able to break it into 26 buckets. Over here is cluster ID 26. It's the largest one. It has 12 reports. And now that we have this set of, or this cluster, we can run a similarity cluster within it. But when all your reports are have gone through this framework, you would also know your most used data points. And data points not as in account number is the most used field, but account number along with these other reports and fields are it takes you to that like a data heat map, 80-20 rule. These are your most used data points and reports. I don't want to say used and consumed because we're not talking about usage at this point, but in terms of the data elements, the grouping of data that is available or that is the most used. That takes us to the next stop, right? Now that we know that these groups or these clusters are the most used, we can generate a pseudo SQL right out of here to provide to the data SMEs so that they can refactor it in their SQL editors or what they may have to create these Tableau data sources that can now, for example, the generated, so in this case, for this ID, I have a generated Tableau data source. And I'll come back to this analysis too, because we have all this information. You can do all kind of analysis in terms of what tables are joined to what other tables and how many reports use certain type of joins and how many reports use external files, how many reports use local joins and things like that. But for each cluster that you have over here, you'll have a Tableau data source that gets generated. And working with this means you can add more columns, more calculations into that generated custom SQL so that you have a certified Tableau data source that can be used. Obviously, that certified Tableau data source will be used for the migration purpose, but post-migration, it could also be used for self-service for your business users to build their visualizations out of. So we've covered the point. We've come to a point where we're talking about every cluster would now get converted into a Tableau data source. Once we have the Tableau data source, we know that all reports within that cluster can be created out of that one Tableau data source. In this case, once I create that single Tableau data source for cluster ID 26, giving it a nice business name, 12 of my Hyperion reports can be converted just out of it. So I'm not doing a standard lift and shift of pick up one Hyperion report, move it, recreate it in Tableau, but I can consolidate that work over here. So that was the second piece of our framework, right? So at the start of this, we spoke about how a framework uses automation and accelerators. We saw some of the accelerators in terms of how we do the deduping, how we collect the metadata, and we also looked at what I also want to talk about is other accelerators such as Pixel Perfect or Write Back. So if you use a lot of Send SQL in your Hyperion dashboards or Brio dashboards, we do have an accelerator that works with Tableau that does, that's called Write Back, that would do that. And if you have a need to email or print what used to be the report section in Hyperion, but if you have that need, that the continued need that in your new world, you would still need to have those perfectly print ready reports available, we have another accelerator called Pixel Perfect that would do that for you. So you could set your schedules, emails, FTPs, just the way you had in a Brio or Hyperion. So coming back to the framework, once the recon and reckoner do that metadata mapping, the reports go into rationalizing a report. This is where you see the output of all the metadata analysis. And as an end product of the report, what we try to do is provide a mapping. Now, this is the final result of the entire rationalizing process where you come up with these are the reports that we're going to lift and shift. We have done the deduping, we have consolidated similar reports. And another part about similar reports is if you have 4 or 5 reports that are similar, you can obviously have a conversation around consolidating them. But at the same time, you may come back with, we need a version just because they're used by different groups for different purposes. At least you don't have to start from scratch. You build the first version of it and then move on to copy paste it to create the next version and to make your changes. So Coming back to the column check spreadsheet, everything that you see in yellow is out of your Brio or Hyperion reports. Everything you see in the bluish gray color is in your new Tableau world. So as a part of Reckoner, we also map the tables and columns with the business or the display names that you use in Hyperion to a sales model, to a Tableau data source that it maps to, and the actual field within that Tableau data source. So in Hyperion world, our analysts are used to saying table name dot column name. In Tableau, you would have a TDS name, and the TDS would have all the fields that are listed out with the business name. So this mapping becomes a very handy tool for our developers that are doing that lift and shift piece after the rationalization, because you see all the fields that you need to build out that query. It tells you exactly what Tableau data source to go to. What are the fields called over there? At the same time, this would also tell you, so for example, to build out the sales query over here, I just need to go to sales model, pick these fields out, rate my cross tab, and my filters and calculations and so on. But in another scenario, it would also tell you the closest map to a Tableau data source and tell you that these fields do not exist. So either you could request for those fields to be added or create a new Tableau data source. But this way, at least you're not going to go 80% into report development just to figure out, I don't have the last 3 fields that are needed. And this also makes development a lot faster, because in traditional lift and shift, you have to go across a lot of mapping files to get to first the decision of what Tableau data source should I use. And then once you have that, you kind of need to know the new business name, because what you're looking at when you open that Hyperion document is the old name. And guys, I know I've gone across a lot of things very quickly, so please, if you have questions, do add questions. So to summarize this, right, our column level mapping saves significant amount of time because the BQIs are now mapped to the Tableau data sources. The Tableau data source gaps have been identified, and this also reduces the number of reports because of the groupings, clustering, the similarity clustering, and also the mapping helps with almost like scaling of your SME knowledge, right? Because now, for example, when you have certain inputs from the data SMEs, you're able to look for those patterns across tens of thousands of reports with a simple search. For example, there could be a sentiment that almost all of our reports have local joins. It's impossible to open 10,000 reports to go for that or look for that. But over here, with this impact analysis, you can just quickly filter out how many of my BQIs have external files, so how many of my BQIs have local joins, and things of that nature. So it just helps with that. And the final mapping also makes it somewhat, then it reduces your need for a Hyperion expert to do that actual migration when moving from Hyperion to Tableau, because all that metadata is extracted and put in that spreadsheet in Hyperion. You can, your Tableau developer need not be a Hyperion expert to do that lift and shift for you. Everything is pre-mapped for them, and that makes large-scale migrations more effective. That brings us to the value proposition of a migration playbook. Obviously, it's mainly around the first line, right? The time to market. The way to do that is to shrink the report footprint, and that's what we strive for through whether you look at our Extractor scripts or through the Reckner mapping capability. That's, it's all around time to market. It also makes estimation a lot easier because you're doing all this upfront analysis. There is more accuracy in this data because of the statistical analysis that's done. And from an estimation point, right, I've been on both sides of the fence as a project manager and as a BI manager. When asked to estimate migration, you're first stumped because you have reports that were created in 5 minutes and you have complex dashboards that took a team of 5 people 5 months to build out. So this breakdown of the metadata and the complexity makes it very easy to ticket size your reports. And just to sum it up, right, when I think of why this framework or the real value of the framework is, first of all, there's a 60% time reduction in just that initial audit, right? The impact analysis, the system inventory analysis. It's easier from a project management and scoping standpoint. Our processes are definitely optimized for business readiness in terms of coach consulting and how you can be successful in your new world. You land up with the easier to maintain and more targeted towards self-service kind of environment because of all the clustering and the Tableau data sources, the reusable Tableau data sources that come out of that piece. I already spoke about how budgeting becomes, or the estimates become more accurate. And at the end of the day, you can apply this SME knowledge at scale. So if a SME talks about a slowly changing dimension, you can run a quick query across your tens of thousands of reports to see where you can find the pattern that the SME is looking for. So you can apply SME's knowledge at scale very quickly without opening these reports. And that brings me to the last part of it, that this framework really, the way I look at it, is designed for sunsetting of the legacy environment, not just for migrating a bunch of reports, but as a design, it helps you look at the whole inventory, gives you a pattern mapping for that entire inventory. So it's set up for sunset of your legacy environment. With that, I'm going to now invite JP to talk about best of breed solution for modern data and analytics platform.
Thanks, Deepak. Good morning, everyone. Now that Deepak spoke about the framework that we use for migrating Hyperion onto Tableau Server, just wanted to walk you guys briefly on the architecture that we propose that has worked well for us for deploying Tableau Server, right? So the architecture that we propose is the Tableau Server that's deployed on AWS, and it is backed by Snowflake data warehouse. And the Tableau Server itself is available in multiple options. So it is available as a product that can be deployed on-prem or on cloud. And we also have a SaaS offering by Tableau itself, that's Tableau Online. The Tableau Online has a few limitations which are listed down here, but the main ones being the data that is on-prem. If you want to connect your data that is there on-prem to Tableau Online, then the only option is to use the Tableau Bridge, which is more like a proxy that we need to deploy on-prem, and that has kind of limitations. And we cannot go ahead and say customize the Tableau Online to our own needs. I mean, the cache settings and the timeouts, that's something that is not really helpful when we're working with Tableau Online. Can we go to the next slide, please? So in terms of the Tableau Server itself, it has like a lot of benefits as compared to legacy BI platforms, where it was mainly designed for delivering data. Unlike Tableau Server, which has like a simple user interface. Can you just click next, please? Here you have like a simple user interface, where one interface for all the actions that we need to perform, be it management or visualizing, or if you want to have interactions with the chart, this is like one simple interface that we can use. It has a very flexible data architecture. We can decide as to if you want to keep the data on the Tableau server or if you want to keep it back in the data warehouse. It does provide built-in tools for automatic and content updates. I mean, we have prep flows, we can subscribe to views and things like that. And it has real good APIs available for embedded analytics, right? These dashboards can be embedded into the corporate portals, and it gives a real good action for users and really good insights for users who want to get information on the portal itself. It's highly scalable, it's completely secure, and it is also available as a mobile app, right? We can just go to the next slide, please. Yeah, so in terms of Snowflake, Snowflake is built specifically for the cloud, unlike other data warehouses. I mean, and it is designed to address many of the problems found in older hardware-based data warehouses, such as limited scalability, data transformation issues, and delays or failures due to high peaks, right? The benefits of Snowflake are it is performant and it is very elastic. We only pay for the services that we consume. It supports both structured and semi-structured data. It is highly concurrent. The data sharing is built into the product itself. I mean, it is really useful when you want to share data across organizations or within the organization. And it also has few data monetization benefits on the data marketplace. It is highly available and secure because it is deployed on cloud, and you can connect your ecosystem to Snowflake with these. There is no hassles. I mean, there's no development required. Everything is already built into Snowflake. Can you just go to the next slide, please? Here are a few benefits of having Tableau Server and Snowflake on AWS. As we all know, AWS is highly agile and it is really scalable. Tableau has a little more flexibility in terms of the products that is being deployed on AWS. It does choose, let us choose in terms of the repository and things like that that we want to use as compared to on-prem. And as we all know, AWS is, I mean, it has unlimited scalability. I mean, we can scale up or scale out based on our needs. In terms of the TCO, we can use the OPEX model. We can pay for the services that we use as compared to CAPEX, where we have to make like an initial investment upfront on the infrastructure and the Windows licensing cost that can be eliminated with AWS. And there are a lot of deployment frameworks that are readily available, like Tableau and AWS have their own deployment guides that are already available. And these are proven frameworks that can be used to deploy them onto Tableau Server within minutes. And we all know that it is really easy to maintain things on AWS because of the services that are currently available on AWS, be it for monitoring or backup or integration. It's really easier to achieve with AWS, and we don't have to look for any other services.